Okay, let me get on to another benefit of stacking the DC motors. All right, let me just show you a side view because that's a little sloppy, hard to see what's going on. Okay, so here's a side view. Um, I think for the purpose of clarity, I'll draw them. I have to show the three-dimensional aspect. Okay, so I'm just going to draw two tall, even though it might be able to get to three tall, depending on how big the motors are and how big the muscle area is. So you got your motor, you got your pulley. All right, another advantage is on the end of the pulley. Well, first of all, the pulley will be connected to string, which is going to come upward. That's an advantage right there. The string is going to come upward and then enter its tubing, which might be mounted right here, and then it's going to flow that way, running along the surface of the muscle along the outside. Okay, so I like that flow of the string for the actuation. And another benefit is at the tip of the output shaft of the motor, I can put a miniature ball bearing type design I created just today, and then strap that down like that to the bone, because the bone will be here. All right. So I'll be able to actually sew this down with thread, tying it off into the bone. So that's an advantage of stacking the motors vertically, is you can tie down the output shaft. Because the output shaft, when pressure is exerted this way on the muscles, the output shaft will want to bend upward. And so in order to counter the output shaft from bending like this and damaging the motor, you're able to tie down the output shaft by these threads attaching it to the bone. So that's really convenient. I like the management of the cables to go up and then over, because then the air can flow without having to get through all those cables. The air is going to be flowing this way. And so the air can flow between these vertical columns that run lengthwise along the bone. You can have as many columns as you want stacked next to each other in a vertical fashion, maybe 3 high. Now, onto more detail on this bearing assembly. So, what I was thinking is a really cool way to do it would be to just create like maybe a metal cup like this, and then inside the cup just have a little ball. That simple. And then the cup could be glued to string that comes down like this and sews into the bone. And the bone is here. Okay. So that's all it is. It's just a concavity in the cup that holds a little ball. And then it's pulled tight down onto the output shaft of the servo, which can have a slight ridge on either side of the ball, which can be added to the output shaft of the servo. And then the servo will have its 3 flanges, and then here's the DC motor. And so the DC motor will have a string wrapped around and then coming up, wrapped around and then coming up. Now another benefit of this, if this ball were a little taller, is you can then attach like a nail from here to here, and then sew that nail into the servo, because all the servos are wrapped in cloth. You can sew it down, and now you've got um, a hard surface mounted from here to here that you can now attach your guide hoses for the muscle fibers onto. You can attach these guide hoses, strapping them firmly to this outcropping. It could be a nail or just a shaft or something that attaches from the top of the DC motor to the top of this little simplified ball bearing. Now, the advantage of this ball bearing is it enables the servo motor output shaft to rotate without well, my first idea was to just wrap string around the output shaft, but if this shaft were rotating back and forth all the time, that would wear through the string. And then my second idea was, what if I coat the string in epoxy? Would that make it last longer? Sure, it would, but that's going to be a lot of heat and friction as this motor is constantly turning. It would eventually work its way through that. So taking a little metal ball and just mounting it in a little concavity, this ball could then be lubricated with bearing grease, and as the output shaft turns, this ball could just spin, and there wouldn't be that much friction because the ball would be greased up. It'd be a little metal ball, and it'd just be rotating in this area, and it wouldn't have anywhere it could go because this concave cup is just holding it. So it'd be like a ball and a cup, and the ball could just turn and turn, and the motor would be down here causing the ball to turn. And I feel like that ball could heat up because of the friction. Even though it has bearing grease, it might heat up a little bit. But if this structure were connected to a nail, which is connected to the servo, and the servo is being cooled properly, or I call it a servo, the DC motor. If the DC motor is being cooled properly, then heat would kind of be distributed evenly and it'd all just be cool. And I don't think that would produce that much heat anyways. So that's how I'm going to prevent this servo output, or this motor output shaft, from bending upward from the muscles being pulling on it. And then obviously I drew this DC motor with a gap here between the bone and it. That gap wouldn't be there. It's going to be mounted flush with the bone. So I drew that wrong. The bone would end right here. So this would be tied down here. There we go. So I corrected it. Let me wipe that out then. Alright. And then the next motor would be mounted right on top of this one, and it'd do the same exact thing. And the strings for that bearing would just be coming down longer. And I think this would work. These strings will be pulled taut, and when this shaft tries to bend upward, these strings will prevent that. So this shaft can't be bent, which would damage the internal structure of the DC motor. And it's very lightweight, very simple design, very easy to make. I'm thinking that this cup could just be like a little bit of epoxy putty. You just mix it up, and then you just shove the little metal ball into it, and then you just pull it back out and let that harden. And then in order to make it a little, you can kind of like drill it out with a Dremel bit that's shaped like this. You can just stick that in the hole and make it a little bigger with the Dremel bit. And then just the ball will be able to rotate freely in there, and I could just lubricate it with a little bit of bearing grease. I think the bearing grease might spray out, though. I'd be concerned about that. I don't know if anybody knows if there's a type of grease that would actually stay in there in this situation without like just spraying out downward and falling out eventually. So that might be a flaw in my design. I don't know. It's kind of scary. But if that's the case, it might not be able to be greased. I don't know. hopefully the grease would just stay on the ball for a long time. I don't know how that would work. I'm not an expert on bearings, but this just seemed like a logical way to remove friction on the output shaft while still pulling the output shaft toward the bone, since the muscles are going to be wanting to bend it up away from the bone. So for the ball, I was thinking I could just use a little BB from a BB gun, but I don't have those. But I actually have shotgun shells, I think, in my drawer. So I might use a shotgun shell. I might open it up and extract the BBs from it and use those BBs as my bearings balls. If not, if I actually don't have shotgun shells, I'm not sure. I could go buy them, or obviously I could just go to the store and buy a box of BBs for a BB gun and use that. I think that's about the size I want. I might need something smaller though. I don't know. I'll have to experiment, I guess. I'm sure buying little metal balls shouldn't be too expensive. So that was very exciting, just knowing how I'm going to be able to mount the DC motors. Because without knowing that, there was just a lot of confusion. I'm so happy I now know how they're going to be mounted. Without knowing how to mount the motors and what orientation, how they're going to be strapped down, how they're going to be cooled, how the airflow is going to run through them, without having the answers to those questions, I was not able to proceed with electronics. And I believe that that was part of the subconscious reason I was focusing more on building the bones of the rib cage than I was on continuing with the electronics of the arm. I just didn't have all the answers, and I needed time to work that out. So I was using kind of like a stall tactic. The bone making, I knew how to do that. So I stuck with what I knew what to do while I tried to figure out what I'm going to do with the motor situation. So now that I know how those are all going to be stacked, we're good to go.